In this video, I'm going to give a step-by-step tutorial of how to make this 3D printed mask. Now, over the last month, I've tested a number of different 3D mask designs, and this one has stood out from the rest because out of all the ones that I've tested, this was the only one that was able to pass something called the fit test. Now, the fit test is a special test that hospitals perform on their N95 masks to make sure that they're functioning properly and that they're going to be safe for their personnel to wear. It requires specialized equipment and expertise in order to perform a fit test safely and get valid results. But I'm a biomedical engineer, my wife is an intensive care doctor, so the two of us have the expertise to perform this test. We also have the equipment for fit testing in our own home, which meant that we were able to very efficiently test the different mask designs that we printed. Once we had a mask design that was able to consistently pass our in-home test, this one here, my wife did take it into the hospital and perform a standardized fit test under the supervision of a respiratory therapist just to confirm our test results. And it did pass there as well. So we're fairly confident in our test results that for at least the two of us, this mask was able to successfully pass the fit test that is the same standard that is applied to N95 masks. Even though in this one regard, the fit testing, this mask was able to perform to the standard of an N95 mask. This mask is in no way as safe as an N95 mask. It should not be used as a replacement for one. We're not encouraging you to wear this as protective equipment. In this video, I'm going to go through the steps of making this mask here, including the 3D printing, the fitting of this mask to your face, the creating and installation of the filters, and then the final assembly. First, I'm going to click on this link here. That's going to take me to the download for the STL files. I've posted this link down in the details below. You should see a zip file start downloading on your browser. If not, check and see if there's any kind of pop-up blocker that's keeping that from happening. If that's not working, or if you can't get the link to work, we can also get it directly from the designer's website. I've also included that link in the details below. Now that we have our STL files downloaded, we can extract the folder and we're ready to import them to our slicer software. There are three main files in here. There's the main in both large and small size. The large fit me well, the small fit my wife. That's going to be the actual mask itself. Then there's two other components. There's the filter hold, which is an internal piece that helps position the filters into the mask. And then there's a locking mechanism that actually locks the filters into the mask. I like to start by printing just the mask. You don't know if you're going to have to maybe rescale it a little bit to fit your face, and any rescaling that you apply to the mask you'll have to apply to the locking mechanism and the filter hold. So I'm going to select the main here because I'm importing an STL file into our slicer, which is Prusa Slicer. And you can see it's appeared in the slicer here. If I rotate it around, we can see what it looks like. There are 4 different holders for an elastic band to run through. There are other designs of this mask that have slightly different elastic holders, so that may look different on your mask. This design is called the balloon mask. The reason for that is because there's this outer balloon you can see here. The rim is actually inflated a bit, so that when you heat it, you can press it into your face and it'll actually conform to the shape of your face and get a much better fit. I actually think this was the main reason that this mask passed and other masks that I tested didn't. I was able to get a much better seal with this mask than with any other mask I used. If I slice in, you can see what I'm talking about with the balloon here. It actually has no infill inside of it. It's an open cavern with 2 walls. And as you heat it, you can then press it into your face and there will be some give to it and it will form to your face. The shape of it does resemble an N95 mask in terms of facial coverage. You can see it covers the nose and then a good width of the face. Some of the masks that I've tried had nose coverage, but then they would actually come down very narrow across the face, which meant that if you made any kind of facial expression like a smile, the corners of your mouth would poke out the sides of that mask. This one has good dimensions to it. It's another reason I think this has performed well. I will say that the 8-hour print time for this mask is about double the other printed masks that I tested. A lot of those fell in the 4-hour range. But the other masks that printed in half the time also weren't able to pass the fit testing standard. So even though this does take longer, I think that the benefits of the additional print time are definitely worth it. Now this mask does not require any supports. You may find different designs do require supports, in which case you're just going to need to go to your print settings and change it to add supports. Now if you want to scale the mask, you can come in here and change the scale factors. One thing to keep in mind is that because the front of the mask is a circle, you have to scale X and Y the same amount, otherwise it'll no longer be a perfect circle and the locking mechanisms won't fit. So now that I've sliced this design, I'm going to export it, take it over to my Prusa printer, and get started with the print. I'm just going to be using the default settings of my Prusa printer for PLA, because that's the filament I'm going to be using. I've selected the design and the printer is started. Here's a time-lapse video showing the print. So you should now have your 3D printed mask. It should look something like this. It may be a little bit different in size depending on which size option you chose or how you scaled it. Now that we have our mask, we should check the dimensions, make sure it's fitting properly. When I put it on my face, it should rest about on my chin, bottom of my chin, not underneath the chin necessarily, but kind of resting on the chin. And then the top of the mask should be on the bridge of my nose. I'm going to place it on my face. We'll see if that's the case. So it is fitting how I would like it. The chin rest is fitting in my chin. This is the nose bridge is fitting on the bridge of my nose. The next thing to test is the width. You want to have it wide enough that no matter what expression you do with your face, you feel like there's a little bit of extra coverage around the edge. So that even when you make a really wide smile, you still want the mask to actually cover even outside of that, just to make sure there's a little bit of extra room there. So as I put on the mask, I'm going to try and make a big facial expression, and we'll be able to see if it pops out in any place as I do it. So even as I'm making these expressions, I'm not seeing the corners of my mouth pop in and out of the mask. That's a good sign. I feel like there's a good amount of width around the mask to cover my entire mouth. Also feel like it's covering the extent I want it to up on my cheeks. So the dimensions of this mask are good for me. You want to do the same test yourself, make sure that the dimensions fit. If it's not fitting properly, you can always try rescaling it in your slicer to be a bit bigger or smaller. Just remember to make sure the X and Y dimensions are scaled the same. Otherwise, you will ruin the circle here, and the filter holder and the lock won't be able to fit in place. Now that we have a mask that is fitting the dimensions of my face properly, we can go back and print out the locking mechanism and the filter holder. So I'm going to go back into our slicer software and pull up those files. Now I found for me that the default size of the filter locking mechanism did not quite fit for the mask. It was a bit too big. That may just be because my printer isn't quite as finely tuned as the printer that it was built for. So I had to actually shrink the locking mechanism. I shrink it to 97% of its normal size in the X and Y dimension. I leave the Z as it is. But just shrinking it a little bit makes it able to fit into the mask for me. You may not need to do this. It may fit properly for you. But if you have issues getting the locking mechanism to fit, you can give that a try. The filter holder I find fits as it is. I don't have to change that at all. So I can leave that in its normal dimensions. I'm going to reduce the filter locking mechanism by 3%. Now that I've made those changes, I'm going to hit the slice button, and I'm then going to be able to export our G-code for these two components. So now we have our 3D printed mask, and we also have the two other components that go with it. We have the filter holder, which rests inside of the mask, and the filters then sit on top of it. And we have the filter locking mechanism. You see there's three different prongs that correspond to holes on the mask. They slide in and they lock in place. Now this is what wasn't fitting properly for me before rescaling, so I had to make this a little bit smaller. When you first put the mask against your face, you may find that there are some areas that don't fit very well. For me, it's the side of my faces. There's a lot of gap between the mask and my face, so it's not fitting very tightly there. For you, it may be some different area. That's not any reason to be concerned. That's normal for this part of the process. We're going to fit the mask, and that's going to help with a lot of those areas. So in order to fit our mask, we're going to need a source of heat. I recommend a hair dryer. We tried using a heat gun, but it actually made the mask too hot, and it was very uncomfortable against our face. And it's also overkill. You can do it with just a hair dryer. So we use a hair dryer set to the high setting. We apply heat to the mask, and then we press the mask into our face. I'm not actually going to do it because it'd be pretty loud for you at home listening to this. So just to show you what I would do is I would distribute the heat pretty evenly. I like to focus on one area to start with, for example the nose, and really get that fitting well. So I would heat that area more, and then once you've heated it, you press it against your face and kind of force it into your face. You'll feel the mask giving in as you press it in. It's going to be uncomfortable. I'll warn you of that ahead of time. It does not feel very nice as you press it into your face. It may bruise your face a little bit as you do it, but it is making the mask fit better. So start with one area, the nose, press it firmly into your face, get it fitting. Move to the chin. I like to get the nose and the chin really fit properly first, so move to the chin, put heat on it real quick. Not too long. If you heat it too much, you can deform the mask. So just real quick, light heat, keep it moving. Press it into your face. Once you have the nose and the chin working properly, you can move to the sides, heat those up. Really focus your heat on this balloon rim inside. Get the balloon rim heated up, and then press into your face. Avoid heating the actual mask itself, the inside or the outside. You don't want to deform the walls of the mask. Focus your heat on the actual balloon. So heat the balloon, press it into your face. When it comes to the sides, it may be helpful to use your other hand to kind of press it in. You don't have to keep holding onto the hairdryer. You can set that down and then really press it into your face and try to warp the sides a little bit. You're bending them towards you, and because there's this give built into the mask, you'll feel it conforming to your face and kind of folding around it. Once I have the chin and the nose working properly and I've done a first pass on the sides and it feels pretty good, what I like to do is do a suction test to see if there's any areas where there's a leak of air. In order to do that, you can put the mask up against your face and then cover the opening with your hand. Then try breathing in through the mask, and if it's properly sealed, you should have no air coming in. You should create a perfect seal and a vacuum up against your face with the mask. That's what we're going for. If you can feel air coming in, that means that there's some area that's not fit quite right. You don't want any leaking areas. For me, it tends to be my nose, so I would feel the air leaking in on the sides of my nose. So do that periodically to make sure that there's no leaks. If you find a leak, apply some heat to that area and then refit that part again. And repeat that over and over again until you have a perfect vacuum when you cover over the front of the mouth. That's the end result we're going for. Make sure that every time you do this test, you give it enough time to cool down before you do it. If you still have warm parts of the mask, say you've heated it, and then you do the test, you'll actually find that the vacuum will suck in on the sides of the mask and can suck it in and deform the mask. I made that mistake with one of these masks and had to then pry the plastic out again. So make sure that the mask is properly cooled between every suction test, otherwise you could deform it. So as you do this, you should see the mask start to conform to your face. The original balloon should start to be pressed in areas where your face was being fit. So you should see the chin, the nose in particular, starting to cave in where you're pressing in against your face. That's what we're looking for. So repeat these steps until you can pass that suction test consistently, and that there's no obvious areas of leak in and around your mask. We found that if we weren't able to pass the suction test for a mask, it also couldn't pass the fit test. So this is the most important part. Get it fit right. Make sure there's no obvious leaks. Make sure you don't overdo this. You could start to warp the mask if you heat it too much. So once you have a fit that is passing that suction test, it's best to stop. Don't keep trying to get everything completely perfect once you've passed that test. That's really a good stopping point. Once we have that, we're ready to move on and start making filters. In this part of the video, I'm going to discuss how we made our filters for the mask. There are a lot of different ways you could make the filters, a lot of different materials you could use. So this isn't necessarily the only way to make them, but this is what worked well for us. We tried some different materials in the process, so I can give you some guidance of whether those materials worked or not. We tried cloth, we tried makeup pads. Those didn't work. They failed pretty early on into the test, which meant that they just weren't going to be viable options for filters for this mask. What we found worked well were air conditioner filters, especially ones that were MERV 14. So we looked for that rating. That was rated to filter out virus carriers, not necessarily viruses, but virus carriers. That's how they framed it in their marketing speak. So we looked for that. And if you don't know, MERV is a rating for filters. Higher numbers is a better filter. It's going to filter out more than a lower number. MERV 13 has some association with hospitals. In order to be considered hospital grade, you had to have MERV 13 or higher. So we found that MERV 14 filters worked well for us. One important thing to pay attention to when selecting air conditioner filters is that you need to check to make sure that there's no fiberglass. If there's fiberglass in the material, you could be damaging your lungs by breathing through it. You'll do way more harm than good wearing a mask with a fiberglass filter in it. So make sure you check the manufacturer's specifications. There should be no fiberglass included in the material at all. Another thing to consider when you're buying your air conditioner filter is they have different ways of being put together. You normally have a metal grid that's covering it, that's holding it into place, but they have different ways of securing that metal grid to the filter. Every time you see a metal intersection, it is being glued to the filter material behind it at that location. What this filter did well is that there's actually a lot of bunching of the material in between where it's glued. So that meant that we had some slack that we could unfold and cut without having the glue being a part of it. You want as much filter material in between points of glue as you can get, and that's why we liked this particular manufacturer's filter. To show you what it looks like in some of the other filters, this is what it looks like when it's glued too much. Here there's a metal mesh, but it's entirely connected to the fabric. There's no folds of fabric in between that we can then unfold to get some material to harvest. So if your filter looks anything like this, it's not going to work very easily. There's no good way to pry this off without affecting the material in between. So one important thing to pay attention to when you're making your filters is the direction of the airflow for your filter. These are designed in such a way that there's a input side and an output side. The air is supposed to come from one direction and pass through in that direction. So if we look at this filter, you can see there's an arrow here that's showing which way the air is supposed to go. It's supposed to be coming from this direction. So when we go to make our mask, it's important that we make sure that the same directionality is being used for the filters. Otherwise, it's not going to work properly. These filters only work if the air is coming in from the right side. This is the side that needs to be facing out of the mask, and this side needs to be on the inside of the mask. So when you are harvesting your filters, make sure you pay attention to that. I find using a pen to denote which side is which before you start harvesting is very important, because once you've detached this from the frame, you may no longer have the reference that you need to figure out which side was the input side, which side was the output side. So I'm going to, with my pen, mark this side. So now that we know which direction the airflow needs to go, and we've marked that on our filter, we're ready to start taking this apart. I'm going to take the air conditioner filter. I'm going to rip the cardboard edges off. We have the filter and we have the wire mesh on top of it. I'm going to start at the edges and start prying them apart. You're going to have a little bit of difficulty at the edges prying the two apart. Once you get past the edges though, it should be easier. You can see there's some moments where it's a little bit difficult. It's not quite coming free, but just keep working at it. Mark any areas where you are tearing it. And now once I'm past the edges and more towards the center, you can see it's pulling apart pretty easily. The glue is not holding it nearly as firmly in the center of the filter, so I'm able to pull the mesh off. So once I have the wire mesh off the first side, I'm going to flip it over, and we have to deal with the mesh on the other side here as well. This will be a little bit trickier because there's not the structure to hold it in place while you're yanking it off the same way there was when you did the front side. Just be careful as you're pulling, go slow. Again, it's okay if there's some ripping around the edges. We're not going to use much of the edge. We're going to really focus our harvesting of the material on the center of the filters. So if there's a little bit of tearing as you're yanking the filter off of the mesh, that's going to be okay. You'll just mark that and not use that section later. So again, once I'm past the edges, you'll see it starts to come off pretty nicely. Pretty quickly here we have our filter with no wire mesh attached to it. Now we've detached our filter material. We need to figure out which side is our input, so look for the dots that we made or whatever sign you gave yourself to indicate the side that should be facing the inside of the mask and which side should be facing the outside of the mask. Just make sure that you are extra clear with your conventions, and maybe make a note to yourself in case you have to come back a few weeks later and use the filters that you've made. So I've located my dots here, saying this is the side of the filter that will face the inside of the mask. So then the air should be coming from this side and going out through here. So now that I've identified which side is the input side, I can start making some drawings on here of the shape of the filter that I'll then cut out. So the easiest way I've found to do this is to take the filter holder piece, this round piece, lay it on the material, take a marker, and trace the material in that shape, because the shape of this is about the same size that the filter is going to need to be. Be sure to label inside of each circle that you draw which side of the filter material is going to be facing the inside of the mask and which side is going to be facing out, because once you've cut it out, you need to still be able to tell which side is going to be facing in and which is going to be facing out. So, off screen, I'm going to do that. I'm going to take this and I'm going to trace many circles the same size, and I'm going to label it then with which side is which. So here I've taken our filter holder circle and used it as a template on the filter material. You can see I've labeled which side is the inside, which means it's going to be facing toward the wearer. Notice I stayed away from the edges. A lot of the material there got ripped as I was pulling the glue off, so I stayed away from the edges on both the side there, but also up top here. Now that I have my templates all drawn up here, I'm going to take a pair of scissors and cut these out. I've finished cutting out my filter circles. You can see I've got them labeled. I've got my 6 filter circles all roughly evenly sized. Before you take the entire filter material and cut out 100 different filters, I'd recommend starting with a smaller number and just make sure that this is going to work. Cut out a few filters, and then you can go and take your own fit test and make sure that it's working for you. Make sure that your mask is properly fitting, that the filters are working properly, and then once you've done that, now you can go back and cut out the rest of your filters from the filter material. So now we're ready to do our final assembly. So we have our 3D printed mask, we have the filter holder, the locking mechanism, and our filters. Now when we performed our test, we did it with a varying number of filters to see when we were able to start passing the test, how many filter layers we needed. We found that if we had less than 3, so if we had 1 or 2 layers of, again, MERV 14 material, it did not pass the test. It actually failed reasonably quickly into the test. So a single layer of this will not be enough. Even 2 layers is not going to be enough. You're going to want to do the same test for your filter material to see how many layers you need. We found that 4 worked really well. The other thing to pay attention to as you're trying out the filters is see how the airflow feels. The more filtering you put in front of the airway, the less airflow you're going to have, and you will start to feel it. We found that if we went up to 5 or 6 filters, we did start to feel it a little bit of discomfort in our chests, a little bit of lightheadedness. So you want to find that sweet spot where you're passing the test, but also not feeling a restriction in your airflow that's having some sort of symptoms presenting themselves. So for us, 5 and 6 was too much, 1 and 2 was too few, so we liked 3 or 4. And just to be safe, we went with 4, just knowing that if there was a tear in one of the filters, there's that little extra redundancy with 4 filters that gave us some extra protection. So again, whatever you're using, you're going to need to do this, test yourself and find what is the optimal number of layers for your given material. I'm going to pay attention to my labels, make sure that they're all facing the right direction, so I'm going to have them all facing the same direction. And then the way I labeled mine is inside faces toward the wearer. So I find my inside label, I take the filter holder, and you'll find there's a bit of a slope to the edge here. There's one side that's flat and the other side has a bit of a slope to it. That slope needs to go into the mask because the mask has a bit of a slope around the rim as well. So it's going to rest into that. Force it into place. You want it to be fairly flat there. We toyed around with the idea of maybe gluing this holder in place, but what we ultimately decided was that it's nice to be able to have it removable. You can come in and out when you're doing the disinfecting. That way there's fewer edges, there's fewer nooks and crannies for infectious material to hide in. It's easier to bleach the inside of this mask. So we leave this loose. Just make sure that you have it firmly pressed in place before the filters go in. It may rock a little, but it should be pretty firmly in there. So I have my filter holder in first. Next I'm going to take my filters. Again, paying attention to the label. They're all facing the same direction. The inside is going to be facing in. I'm placing them inside the mask. It's okay if they bunch up a little bit. You don't want them to fold up too much, but you want them to be able to fit inside. A little bit of coverage on the edges isn't a bad thing, as long as they are resting tightly up against the edge of the mask. It's okay to have a little bit of overhang. If you have a gap there, if your filter isn't quite wide enough and you can see the inner plastic at any point, that means that your filter isn't big enough. You need to go make some bigger filters, just because that could be a source of leaking through your airway. So you want a little bit of overhang, not too much because then the filter lock won't go into place, but a little bit of overhang, and then I like to kind of crease it a bit and fold it up along the edges of the inside of the mask. So now that I have that in place, I'm going to take my filter lock, pay attention to where the prongs are oriented, match them here. Because I've made my filters a little bit bigger, you can see that I'm going to have to kind of place this in through the filter, in that I'm having to kind of force the filter down at the same time as I'm putting the lock in. So there, I have the lock through the holes, the prongs are threaded through the holes, and now I'm going to give it a turn to the right, and that locks it in place. One way to tell if you have the right number of filters or too few is if you have the right number, this should be very firm. It shouldn't be able to wobble back and forth. We found that if we only had one layer of filter, this would have too much give to it, and it would wobble as we moved. The lock wasn't really firmly pressing into the filters, pressing into the filter holder. So you really want to have enough filters in there so that this lock isn't moving when it's fastened into place. So now I have my filters installed, I have my mask properly fitted, and it's time to do a dry run of putting it on. So I'm going to hold it up with my face and just make sure that I'm getting enough airflow. I don't feel dizzy, I don't have a headache, I don't have any pain in my chest. Make sure that it feels appropriate. So that feels pretty good. I can definitely feel it's filtering my airway. I don't have a normal amount of air coming through, but it's not troubling. I'm not feeling any kind of discomfort from the restricted airway. So this is probably pretty good for me. I would now go fit test this with our equipment, or take it into the hospital to have it fit tested. When it comes to fastening it to your head, a few different options here. For this holder, you can have anything you can thread through here. If you can get an elastic through, You can tie it in place, or we've used buttons to kind of be a fastener to it. You could also attach it to a paper clip and thread the paper clip through there and kind of hook it on if you're looking for an attachment that you can unhook and rehook quickly around your face. So we found those were workable solutions. There's also other filter holder designs that are a loop, and then you just kind of take a rubber band and you loop it around, and then it goes around your ear. So that's a nice thing to have. When you print those, though, you will need to print them with supports, so that'll add some time to your printing. So I'm not going to go through that work here. I'll let you figure out how to fasten it to your face. Everyone's probably going to come up with a little bit different solution there. As long as it's able to hold it tightly against your face, and you can feel it's in the right position, you can feel it's tightly sealing all around the rim of the mask up against your face. That's really what matters. In this video, we've gone through the process of printing a mask, fitting it to our face, creating and installing filters, and then the final assembly. I hope you found this helpful. If you have questions, feel free to post them in the comments. I'll do my best to stay on top of those. And again, if you are planning on wearing this mask in any kind of medical or first responder situation, please be careful. There are a lot of risks associated with a 3D printed mask. It is not as safe as a standardized N95 mask or even many other forms of personal protective equipment. So be very careful, limit the duration of use, avoid active situations where you could be hit in the face or you're risking tripping and falling, and just pay attention to how you're feeling while you're wearing it. That's going to be very important. Clean it thoroughly afterward, just to make sure anything that you may have been exposed to is no longer on the mask. And if you're in a situation where you're desperate enough to be thinking about using this, I'm sorry. Good luck, and I hope that this helps.